Okay. So my name is Fabrizio Nunnari. I work with Alexis Heloir in one new research and development laboratory in Germany. So we are one Italian and one French. We work in English, we live in Germany, and we like Spanish both. It's a pretty international team. And before I forget to mention, we are looking for people to join the team, experienced developers that want to start a PhD in computer-human interaction, but maybe before accepting the offer, it's better if you see the presentation, if you like the subject. Okay, I will present briefly the activity we make at the laboratory, what is our long-term plan, and what we did with Blender until now. The research team is very new, it's very young. We established only 1 year ago. I work there since January, and since March we started to use Blender to conduct our research. And so we are pretty new. I'm pretty new in Python and Blender development. But I will present the plugins we developed so far, and I will give some technical details at the end. So our laboratory concerns sign languages. Sign languages are the language spoken or signed by deaf people, which are gesturing to communicate with each other. And the location is Saarbrücken, is in Germany. There is a research center with public funding, and we work there as researchers. The topic are, in the past, the topic of research of the laboratory were the synthesis of sign language. So given some instruction to animate a virtual interpreter that is speaking the sign language to deaf people. Now we are focusing more on the interaction to allow deaf people to animate characters using the new trend that is natural user interfaces, namely Kinect and Leap Motion, that are the devices that are now available on the consumer market. To give you an idea of what is a virtual interpreter, I show you a short animation. So this is the outcome of a project I was working before in Italy that lasted from 2009 to 2011, is the Atlas project. It was about building a complete translator from written text to animated virtual interpreter. The topic was a weather forecast. And you have an idea of which kind of animation you are expected to do. What is the problem with this approach? Was the problem that is the same approach of every project. You first need a professional team to build the signs. You build something like 2,000, 5,000 short animations that are lasting less than 1 second. It's a very boring job for the animators. But you need to populate a dictionary. And then there is a bunch of software and procedures that are merging together these signs, not only as a sequence of animations, but they have to deform the animations according to the context of the sentence. The location where the sign is performed has to be adjusted in space. The facial expression can be different from sign to sign. And so you have to, in real time, merge different subtle components of the facial expression with the main body motion. We work on this long-term goal to make this architecture, where the deaf user at home will be able to populate a shared dictionary with using natural user interfaces. So the basic idea is that at home they use the Kinect and the Leap Motion to make a new sign. These are not motion capture devices, so you cannot have a perfect sign. Then you perform some data cleanup, and you can enter this infinite loop of improving the sign using the same natural user interfaces to edit the character posture. So basically, the purpose is to give a very easy to use tool to make a character animation to deaf people. But it has not to be a very professional, full-featured animation tool. It has to fulfill the needs of animating signs for the sign language. So what we did, when we started to work on this topic, we realized that we needed a flexible platform to develop this architecture. We needed something able to render in real time, to have a feedback in real time of what to do. We needed already some controls and like the 3D widgets and the IK chains to animate the characters. We needed for sure the possibility to script to add the features to the platform. And even if now we are working only on the main character animation using IK controllers, in the future we might need to do some geometry analysis to detect collision, self-body collisions, to improve the quality of the authoring. And we needed to take input from external SDKs and devices. And of course, one of the strongest points of Blender is its cost. And we found that Blender has all these features. So we started to try. In a couple of weeks, we became Python developers. We started to study the API of Blender. And we started to make our experimentations. And these are the plugins that I'm going to present you that are now supporting the architecture I presented. So one module to animate the face of the avatar using your own face. Another module that is able to animate the arms of the avatar using your own arms to make a mirroring, something like a motion capture of your hand motion, but also using your hands instead of the mouse to lay out the objects in space, which is working also in a different context, not only for virtual interpreters animation. And a module to automatically simplify the captured animation curves. All this software is, by the way, already available online. We are making everything open source, and you can follow this link, slsi.dfki.de, and you find a link to the software and the resources, and you can download the plugins and try yourself in Blender. What we use, in addition to Blender, to conduct our work is some hardware you can find on consumer market, Kinect and Leap Motion. We are currently using a software to capture the facial expression, Phase Shift. It's a commercial software, but we think that in future, facial expression detection will be available also in standard and free development kit coming, for example, with the Kinect 2. We are not sure 100%, but we think it is very likely to happen. For the character generation, we use Make Human. That is very well integrating with Blender. And if there is some of the guys of the development team of Make Human, I would be really pleased to talk with them, because I'm going to use Make Human in the future for different also research lines. And to communicate with the Leap Motion, we use a WebSocket library as an extension to the Python libraries. So the first module, basically, as I told you, is to use your face to drive directly a Blender character that you see on the upper right corner. It's a model command. It is suitable also to record animations. So you can record, see in real time your facial expression reported in Blender and record the animation. We use the Leap Motion to as I said, there are two things: to capture the motion of your hands and also to position objects in space. And we developed this curve simplifier that is, I started with a plugin already existing in the set of plugins that you can add to Blender, or no, it's distributed with Blender as a curve simplifier, but we needed an additional feature. We wanted to be able to select multiple curves and simplify them at once with the keyframes of all the curves aligned among them, so that when you simplify a bunch of curves, as you see in this, all the keyframes of the different curves are aligned at the same timestamp. And these make it easier. For example, if you want to then perform some time synchronization between the facial expressions and the body movement you recorded separately. And as I already say, we use also the Leap Motion for general purpose object manipulation. You can translate, rotate, and objects in space. And there are a couple of custom controls, like the making circles with the finger. You can adjust the elbow rotation of the character. There is a video showing this. so you have a better idea of what's happening. And I presented this video last week in Chicago. There was a big conference about sign language technologies. So first of all, you can perform with your face, and here is side-by-side the face shift that is detecting the motion of the face. And we developed a plugin that, via networking, is transferring the blend shape information from face shift directly to the control rig of Blender. I want to stress that we pilot the control rig, so after recording the animation, you can still use the controls to adjust the facial expression. You can use the Leap Motion to perform movement and record the animation of the arms. And then you can use our plugin to simplify your data. It's a very old method to extract meaningful keyframes from very dense sampled data. Normally, they used this technique in the past to extract key postures from motion captured data. So this is the animation, the noisy animation that comes from the recording. Some operation to select the curves. And then with a single slider, you can simplify everything. And this is the resulting animation that the keyframes have been reduced from more than 100 to only 20. And as a side effect that we like is that the motion is more clear, is less noisy, because somehow this simplification is cutting away the high frequencies of the motion. And finally, we use the Leap Motion. After selecting a controller, you can use your finger to adjust the position of the controllers or any other object in space. You can use the fingertip to translate. The rotation of your hand to rotate objects is not a mirrored mode. You really, something like you grab the object, you rotate, and you release it. Currently, with the support of the keyboard, but we are working on a keyboardless mode, which is using some timeouts to avoid using the keyboard and adjust objects in space. And then, as I said, you can perform circles to adjust the elbows. It's really time-saving. Instead of going there to select the controller and translate the controller of the elbow in space, you can just move your fingertip. And yeah, the same with the other hand. Okay. So, technically, these operators have been developed using totally only Python. So this is some technical details about the facial expression recognition. We have an external application, which is face shift. I found them out. OK. Which is sending the information of the blend shapes via UDP channel. There is a panel programmed in Blender in Python, which allows you to control several commands to record, to fix a keyframe, to reset the keyframe, to reset the facial rig. But especially this command is a modal operator that allows you to keep on taking the data from the network and real-time animating the face. And as I said, we control the control rig. So the animation is not made on the primitive blend shapes, but on the control rig that afterwards the artist can still adjust by hand if desired. The architecture of the operator using the Leap Motion is a bit more complicated because the main operator is activated by pressing one of the control keys. According to which key is activated, is pressed, one or more of the submodules are activated in real time. For example, I can at the same time translate and rotate the object. But what's happening? In the moment I invoke the operator, I have to dispatch a thread. This thread is taking the data from the Leap Motion software, which is installed on your machine. The frames, the information of the Leap Motion are stored in a shared data structure in memory, and this operator is taking this information to derive, together with the orientation of the camera of the active viewport, and is using all this data to derive the position and rotation of the object in space, or of the elbow. And this was not my desired architecture, but it's somehow a constraint I had to do for the limitations of that I found in developing the plugins. So now the good and the bad. The experience of using Blender for fast prototyping has overall good. We have been able to develop a lot of stuff in few months, and consider that actually I am the only real code typer. We do the interaction design all together, but it's one developer that is not even working full-time on developing. So this result in only 6 months or 7 months of activity is really good for us. The API is very rich. You can control almost everything from the single vertex to the animation curves by code, and this is amazing. I also really like the feature that you can just pose your mouse over a button and have the code. You can see the code that you have to invoke to use this operator. It's really fast to transforming code, the operation you do with the user interface. And using Python allows you to use a lot of libraries for collections. The multi-threading networking is all included in Python 3.3, and this is very positive. But what made my life difficult in the past 7 months? I had to realize by crashing my head into the monitor that there is no multi-threading support. So if you dispatch a thread and you invoke operators in Blender using another thread, everything is crashing. And this was not, I didn't see it clearly documented. I didn't know it, and it caused some problems, but now I know it. And that's why the architecture of the plugins is a bit more complex. Oh, okay. Because one of the biggest issues is that I didn't find, using only Python, a way to, let's say, instantiate something like an infinite cycle, a timed cycle that can be used to take data from the network, and if not, running a model operator. And this is was really a problem, because model operators are somehow synchronized with the refreshing of the windows, and you cannot really take data from the network with a pausing call inside the model operator. Everything will freeze or become slow very, very easily. And the other biggest problem is that with the current architecture, in the moment I want to listen to the Leap Motion data, I have to run a fake operator, which in fact is not doing anything on the GUI. It's just there running to take data from the network. And it's running on a certain context. When I have some kind of event from this operator, I want to invoke another operator that is actually moving the object in space. But the context of execution is the same of the first operator. So if I want to simply move the mouse over another window and move the object in another window, the problem is that I cannot access to the view matrix of the second view. This is very technical. I don't know how many of you are following me. But there is somehow a discrepancy between what the user sees as a window selected and the meaning of the current working context and what I actually can see from the code. So I say again, I'm relatively new to Python and Blender development. If there are any suggestions on what is a better way to do this, I will be really happy to talk about it later in private, maybe. So, conclusions. What if I can ask something to Santa Claus for this Christmas about some help in Blender development? First, I have to say, for me, fast prototyping means do not go to the source code, C++ code of Blender and recompile it. Fast prototyping means that we want to be able to script quickly, something to quickly see the results. But if we have to dive in C++ development, is not fast anymore. Given this, I was a bit surprised when I wanted to try a few weeks ago. I got one of these 6 degrees of freedom devices. Is a 3D connection camera navigator, space navigator. It's a device that is meant to be used to navigate in the space, moving the camera with the translation and rotation in a single one-hand device. So I plugged it in my computer. I wanted to read the data to manipulate objects. We want, for scientific coherency, compare the use of a 6 degrees of freedom device with your hand, which is another 6 degrees of freedom device. So in the moment I attached the device, I was working with an SDK to get the information, and I realized that in Blender I could move the camera. Well, this is not nice for me. Maybe it is the standard intended feature, but for me it was a disaster. I mean, I don't want to move the camera. I want to write a MyPython script to move the object. So the solution will be, I will attach the device to another computer. I will stream the data across a network to the computer running Blender, because I found no way to disable this device. And a more general consideration about this is that we don't have control to the interaction design, to the logic of the interaction of some devices. It will be very nice to separate the integration of new devices with the logic in which they are used to manipulate the interface. As far as I understood, all the code about this 3D connection device is all in C++, hard-coded in Blender, and there is no way to have the raw data of the device to write a plugin with a different behavior, a different logic between these. So if I have to ask something to the Santa Claus developer of Blender, it will be, for the future, it's really amazing that in Blender you have the support for many external devices, like the joysticks, this 3D connection, maybe other devices, but it will be really nice to have a separation to live at the high-performance C++ code, the integration of the device, but expose an abstract API so that in Python you can write new code, new plugins that can be used to use these devices with a completely different logic. This will allow developers, plugin developers, to experiment with different interaction paradigms and to do fast prototyping even better than now. That's all.
Okay, thank you. We have to move on with the schedule a little bit, so we don't do a big Q&A. But I can give you a quick reply to your last topic. That's very much known. There's more people having the same issue. There's not a design limitation. It is simply unfinished API work. So operators were never meant to be used the way you are doing now, which is working, but it's a hack. It's very bad. It's not. So the operators were meant to be controlled by handlers, event handlers. And what we need is Python access to the event stream. That's what you want, a threaded events input, and then you can control via operators what happens. The end of device is an event stream which is connected to operators. And you can easily disable this. And if you go to the developer session later, that's on the schedule, you had 3 days, we can lead you through some code, where to find things, or how to configure events and operators better. That information is there, and there's plenty of people who know how to do this.
Okay.
So we can help you with this conference.
Good.
Yes, thank you.
Very appreciated.
Then we move on immediately to the next talk. Who is that? I'm having... Ah, that's right. How much are we behind? 1 hour still?
Yeah, 1 hour.
Ooh.
Well, 50 minutes.